All right, tonight on the bench, we have my PlayStation 1 again. This is a 5501 model. I've been asked to make a video, although I can't really film myself soldering, but I can take short clips and stitch together and kind of explain the process and the tools needed. So, of course, tonight's project is going to be a power supply recap. So this is just preventative maintenance. I got this from Console 5 for the Mitsumi power supply in this PlayStation. Before you order this, you have to make sure you know what kind of power supply you have. I'll show you how to disassemble this and find that out. I've already taken this apart to do the X-Station mod. But tonight, I'm doing the power supply recap and a HDMI mod with my kit. There's not labeled, but my PS1 digital kit. So what you need is a digitally temperature-controlled soldering iron. I have this KSGER T12 soldering station. It takes Hakko T12 tips. I'm using, for the recap, I'm using a, trying to get that to focus, I'm using a chisel tip, D12. I've already tinned it. Got my sponge wet, some brass wire sponge for cleaning the tip. All you need to take this apart is a Phillips screwdriver. This is a number 2 Phillips head. Got my new and improved solder sucker. This is the SSO2 Japanese-made engineer solder sucker with a silicone tip, which if you're going to use a manual solder sucker, this is the one to go with, because you can press that as long as you're soldering below 350 or less Celsius. You can touch the silicone over the joint and you're not going to melt it like those cheapo Teflon tipped ones. So my tweezer pack, if I need that. Of course, isopropyl alcohol. I have a big bottle of the 99% stuff that I put in these small little dispenser bottles with needles. Some MG Chemicals No Clean Flux. Flux is your friend when you're soldering. Some jeweler's loops for magnification. Additional T12 tips. For the PS1 digital, I might have to switch to a small hoof tip or a needle tip for that GPU pin soldering. Some new helping hands. I'm not really going to use the helping hands, but I mainly got this for the swivel magnification, which is also lighted. That should prove helpful. And of course, solder. I'm just trying to use up some of my Radio Shack silver bearing leaded 62362. If you're curious about what these numbers mean, if you don't know, this is the percentage of elements in the alloy. So this is 62% tin, symbol SN here. PB lead, so 36% lead, and AG is the symbol for silver, so this is 2% silver bearing. You can also use just like regular 60-40 lead solder, but I have some of the silver bearing lying around. Really thin soldering. I'll explain later why you want thin wire solder, and this is Rawson core solder, so it does have some Rawson flux inside it, but again, you're going to want extra flux here. So the first thing you want to do, I'm going to get the magnifier out of the way, is make sure you de-energize. Actually, I should do that first. Go ahead and de-energize the system. Just actuate the power button a couple times. That'll just de-energize any current stored in the capacitors. And again, I've already opened this for the X-Station install. This is a 5501. This is one of the few models, if not the only model, that's actually compatible with both mods. The X-Station optical drive emulator and the PS1 digital HDMI. These Sony PlayStations are nice in terms of disassembly because anywhere you need a screw at this stage, they put these little arrows. So you just need to take out these 6 Phillips head screws. So I'm going to go ahead and do that and pause the video and resume in a minute. All right, so with those 6 Phillips head screws removed, I'm going to flip the unit over carefully because the top and bottom halves are now separated. Well, they will separate. So you want to, I'm trying to do this one-handed, so not having much luck doing it one-handed. But you want to I've got the X-Station mount in here, so I have to be extra careful lifting this out so I don't yank out the mount. So we're not going to need the top half of the shell anymore. So this is my X-Station SD card mount. I'm going to go ahead and eject this SD card. I've got another one I'm going to put in there. This is just a small one I used for testing it. So, okay, so if you have a stock PlayStation 1, you're gonna have an optical drive assembly here, but I've already done the X-Station modifications, so I have the X-Station optical drive emulator. If I lift this SD card extension, you'll see it there. This allows you to run games from an SD card, so you don't have to worry about dying lasers or laser motors, that sort of thing. So this is the power supply. This is the first thing we're going to work on. So if you examine the board here, you'll see some identification marks here. In particular, SR679 146218-22. That's the model number, and at the top you'll see Mitsumi Electrical Company Limited. So this is a Mitsumi SR679 power supply for a PlayStation 1. So you need to make sure you're ordering the proper kit. So I'm going to go ahead and unplug the power supply from the motherboard. You don't want to yank this out by the wires. You'll damage them that way. You just gotta kind of grasp the connector, and of course I have huge fingers. You know what? I'm going to first remove the controller assembly. There's a little ribbon cable here. You just grasp this plastic part here, pull it straight out. Doesn't take much force at all. So now I can remove the controller ports and the this is the assembly for the controller ports and the memory card slots. So these are different size screws. So I'm putting them in a different compartment on my magnetized mat here. There's only 2 of these Phillips head screws here. The PS1, you don't need any special screwdrivers like a Nintendo Game Bit or a Tri-Wing or anything like that. It's just basic Phillips head screws. And you'll see little arrows here as well, showing where you need screws there and there. So put that with there. And now once you've freed the controller assembly, it just kind of lifts out vertically. We'll set it aside. So now I should have an easier time getting to the power supply connector. So that connects power to the motherboard. And let me see. So I need to unscrew these 2 Phillips screws here and here. And again, there's those arrows. These are holding the power port and power supply to the lower part of the PS1 chassis. I think these are the same length screws, but I'm going to set them aside anyway. Actually, I'm going to put these 2 controller screws here. Put the power supply screw there. This is a North American NTSC version. I'm in the United States. So I'm sure this will look quite a bit different if you have a PAL region unit. Those typically run off 220 volts. All right, and let's see. Does that free it? Check here. Yep, okay. I just don't want to yank it out. So now we've liberated the power supply from the chassis. So we're going to move the chassis to the side momentarily. Now, I like to use a capacitor map when I'm doing a capacitor replacement, so I can mark off which ones I've done and which ones need to be done and write down the values. This one doesn't have that many. I mean, we're not replacing all the ceramic caps. We're just replacing, so these blue ones are ceramic capacitors. And we're not messing with those. We're just mainly interested in replacing these electrolytics here. Again, this is preventative maintenance. This power supply is probably going on 20 plus years or more. I don't remember offhand when the PS1 launched in North America. But anyway, so this is just for peace of mind. I mean, this unit's been working fine, but I figure if I'm doing all this anyway, I might as well. Let's see, I don't see any signs of leakage. I'm just looking under these capacitor legs. Don't see any signs of leakage on the motherboard. Now, when I took apart my Dreamcast power supply, I did see leaking capacitors. But I don't see any of that here. But again, this is more for peace of mind. The main key is to get your capacitor kit. I like the ones from Console 5. He uses quality parts. And again, this is for a Mitsumi power supply. You want to make sure the, if you've never read a capacitor for these radial can style capacitors, these are also tend to be rated for longer service hours than the factory ones and for higher operating temperatures. The voltage has to be the same or higher. So if you're replacing, so let's see, let's take a look here. This big boy. So this one right here on the board, let me get a focus. Okay, so this is a 200 volt, 120, that's the Greek letter mu, so that's microfarad. F is the, capital F is a farad, that's the unit of capacitance. So unless you know what you're doing with electrical design engineering, you want to match the capacitance value, unless there's like a service bulletin or something saying to swap it for a different value. But the voltage can be the same or higher, so it's not going to hurt to put, say, a 250 volt cap here, as long as the capacitance is the same. So it's 120 microfarads, 200 volts. And is this the one? There's the, no, that's 150. Yeah, I may have to consult the documentation from Console 5. They may have a reason why they've swapped that out. But let's just count our capacitors here. So 1, 2, needs to quit rolling. I guess my table's a little uneven, or my mat is. 3, 4, 1, 2, 3, 4, 5 capacitors that came in the kit. And let's see. Oh, no, there's one down here. Okay, roll down. So 6 capacitors came to kit. 1, 2, 3, 4, 5, 6 electrolytics. So I'm going to stop recording and see if there's a reason why they substituted a 150 microfarad for the 120. If I'm guessing from the design, that's the primary power filter cap. This is your power coming in from your AC mains, your fuse, of course, some resistors and diodes. I'm guessing this is your AC to DC transformer, I think. I'm still kind of learning all this, but I'm pretty sure that's a transformer. I'm thinking that's the main power filter cap. I'd have to look at the schematic to be sure. But I want to see if there's a reason why they swapped this with a higher capacitance cap, a 150. Voltage is the same, 200, before I proceed. All right, so I did check the Console 5 website, and they do, in their kits, they do mention that this power filter 120 UF cap does get replaced with a 150 microfarad, so we should be good to proceed. So, I'm just going to start on one end to kind of work my way across. So what I like to do on these boards is usually there's a designator for the capacitor. So you see right there, C104. This and then it's right next to the circle. So C stands for capacitor, and that's capacitor number 104. So this is C104, and the reason you want to know that is when you flip it over to find the legs to desolder this capacitor, there's the capacitor symbol. It looks like the bars with the backslashes going in between them. C104. It's these two legs here, and it denotes the positive terminal here, and on the other side of the board, that little white mark. It might be different depending on what motherboard you're working on. That's the negative part. And you may say, well, Tim, you know, how do you know, let me move this voltage regulator out of the way here. How do you know which end of the capacitor, you know, if you get a new one, which end is negative, which end's positive? These radial leaded, well, as in they have leads, these leaded caps, these radial electrolytics will have a band, a stripe. It could be different colors. So on this this capacitor here, it's a silver on black. Here's another brand of capacitor. It's gonna have, this one has a gold on blue. That stripe on the capacitor is saying that side's the negative terminal. You definitely, these electrolytics, they do have polarity, and it does matter. If you put them in backwards, you could blow a cap, or, you know, short out, blow a fuse, or all sorts of things happen. So you don't want that to happen. So we've located C104, and we're gonna do the same thing with all the rest of these. And since I don't have a desoldering gun, I'm just gonna introduce some fresh solder to these points here to mix new solder and flux with the old solder. And then as I've heated the solder to a molten state, introduce the solder sucker and suck out the solder. Make sure the pins are free. You don't want to lift the trace and wiggle it out. You just got to take your time, be patient. I don't have a way to film that while I'm doing it because I'll need my hands free to actually do the work. But there are plenty of videos out there on how to desolder through-hole components. That's kind of my approach. If I can't get it all off with the solder sucker, I do have some desoldering braid over in my parts bag here. All right, time to get working. All right, so I've removed the solder with my solder sucker. Came up pretty good. You don't want to just yank this thing out though, because you could risk ripping the copper off the traces, which are those little plated pads around the legs. So I noticed it was wiggling, but it didn't want to come out. The legs were wiggling, but there's still a little solder stuck. So what I did was I kind of, with one hand, brought in my tip with my soldering iron and heated, kind of used the wedge shape of it to heat the pad and the pin at the same time, and just gently wiggled it from the other side till it kind of came out. And again, you just got to be really gentle because you don't want to rip. If you rip a trace, that's going to be a pain to repair, if not impossible, depending on the circuit. So bye-bye to this cap. It is out. So before I go further, though, I just want to make sure the traces are okay. I'm guessing that's just expired flux on there. So I'm going to bring in my isopropyl alcohol. You want at least 90% for this. I like to get the 99%. Put a few drops on there. Get an old toothbrush. And there we go. So it looks like the pads are in pretty good shape. Let me get a little bit more isopropyl here. That one pad's got some stubborn flux on there. Yeah, it does not look like I actually lifted the traces, so that's good. So now you flip it over and we have the empty. Kind of want to wait for that alcohol to dry. Thankfully the higher purity stuff dries pretty quickly. And I did use plenty of flux when I was desoldering, you know, dripped it on there before I heated the solder and sucked it off. So you're going to take your new capacitor, and again, remember, the white mark is your negative. Match that with the band, and you'll want to, now typically also, another way to tell is the positive leg is going to be longer, but the surefire way is to look for that band to find the negative. So of course the other side is going to be the positive. So match that band with the white mark there. Go ahead and get it started. Trying to do this one-handed while I'm filming is not easy. And now it's going to just fall right through, right? Unless you bend the legs. So what I like to do is take one hand and hold the capacitor in place while I'm going to do this off camera. So just bear with me. I might be able to do it one-handed. And I like to kind of, again, you don't want to go nuts with the force here. Kind of bend these in opposite directions. And now that'll kind of hold the capacitor in place. Let's see if I can get a better hold here. Sorry for the shaky cam. There we go. That'll hold it. That'll hold it in place. So, and then what you want to do is put a few drops of flux. I mean, you don't want to coat the whole board, but you know, don't go sparing with it. And then you'll want to bring your soldering iron in. Now, a mistake a lot of people made, and I made, I'm by no means an expert, but I've been doing this for, you know, about a year or two now. You don't want to glob a bunch of solder on here and try and just dollop it on. What you want to do is bring in your tip. I like to use a J tip or a chisel tip, depending on the size and the, you know, the angle I'm having to go at. And you want to kind of put it at an angle where you're heating the pin leg and the pad at the same time, and then as you're heating it up, you introduce your solder and just slowly feed it in. So, and you want a good like kind of a volcano shape, and you want it nice and shiny. That's an indication you got a good hot join. You don't want a cold join, which will look kind of pitted, cracked, or cloudy looking, because that means there might be some cracks and it might not hold up under thermal stress. So I'm gonna go ahead and solder these on and show you what the finished solder looks like. Okay, so I have soldered it on, and we have some good shiny mounds there. This is before I even clean off the flux residue. So let me do that right quick. Bring in your IPA. Let's switch to my other toothbrush. I just like to use El Cheapo toothbrushes. They're pretty good for getting in there. All right, and we have good, looks like good clean joins. Let's check the other side. All right, looks like, I mean, it's not, looks like this is a, looks like this might be a single layer board. So you don't see, notice you don't really see any traces on this side. This is just the fiberglass and the silk screen. If it's a dual layer board with a complete through hole, you would expect to see some solder wicking up through there. But this appears to be a single layer board, so it's fine to just have it here. This is where the traces are. So the capacitor's in place. Let's double check, make sure we have the orientation. So this is our negative, and it's matching the negative designation here. So if we flip it over, that side would have been the negative, no stripe, matches the positive there. So it looks like we are good to go. So I'm gonna bring in my flush cutters, which I thought I had out. I may have left those in my office. You don't want to leave those legs like that. Yeah, let me go grab my flush cutters. I think I left them. I'll be right back. Okay, I got my trusty flush cutters here. So what you want to do is cut these leads, excuse me. You're going to cut these leads, but you don't want to, this is a mistake I've made before, you don't want to cut into that solder mound. You want to cut just right where the leg's coming out. So you don't want to cut into the solder like you're chopping off the top of your little mountain or volcano there. You just want to clip these legs. There's no way I can do that while holding my phone camera. So I'm going to do that and then show you what it looks like afterward. All right, so here we are. We have replaced one of 6 electrolytics. You can see I got it a little close on the positive leg, but I mean, we still have a good mound there. And I left a little bit of the leg sticking out there. I mean, if you compare it to the pins from the factory, as long as you're not sticking out too far past that, you should be fine. You just don't want it grounding out. Now, in this case, there's really nothing to ground in the case of the PlayStation 1 power supply because the bottom is plastic. But sometimes you may have like a RF shield or some kind of metal that might serve as a ground plane. You don't want these pins causing a short to ground. But, all right, I'm going to go ahead and do the rest of these. If I had a capacitor map, I would mark off which one I've done. But actually, a good tip, now that I just thought about this, is to go get a Sharpie and mark an X or something, or a dot on the top of your electrolytic cans, your can caps that you're replacing. And that way you kind of have a visual indicator which ones are left to go. So I'm not going to do that on camera, but that's, you know, my goof. I'm going to go ahead and finish recapping this. Be back in a bit. All right, we've completed the recap or capacitor replacement on this Sony PlayStation 1 Mitsumi power supply. So I went ahead, before I proceed further, marked all the old caps, tops with permanent marker, and got shiny new caps. So a lot of these are also rated for longer service life and higher operating temperatures. So the main power filter cap here is a it's a slightly higher capacitance, which is fine according to the Console 5 guide. But notice it says here 105 Celsius. So the existing cap is actually only rated for 85 Celsius. So you generally want to get higher temperature caps if you can swing it, mainly because they tend to hold up better under thermal stress and give you longer service. So this thing is ready to go back in. We'll go ahead and inspect some of our soldering work here. So let's see, there's one of them that was replaced, C202. Yeah, let me reverse this here because all the numbering is going to be upside down from your point of view. There's C202, got some nice shiny fillets and mounds. C201, welds look good there. Don't see any cracks. And, you know, I checked all these afterward. These I can kind of check with the naked eye. They're really small. If you have really smaller ones, you might need something like jeweler loops or this magnifier. Now, this one, C111, or was it C101? Let's see, where was it? Yeah, C111 is the electrolytic here. I think C101 is, no, it's IC101 is the integrated circuit. So C111 there, I wasn't quite sure what was going on here, but you may say, well, Tim, you bridged that to that diode there. Those pads are actually coupled if I were to remove the solder, those pads are actually shorted anyway. That's how the original factory solder looked. But rest of our solder joints look pretty good. I cleaned off the flux, and we're ready to reinstall this into our PlayStation 1. So I'm going to take the old capacitors and put those up here. Move the power supply to the side. I'm going to bring the PlayStation chassis back here. And I'm going to go ahead and screw this in, but I'm not going to connect it to the motherboard because the next mod, the next project is going to be to remove this whole assembly to get to the motherboard and start soldering for the HDMI mod, the PS1 Digital by Dan Coons and those guys over there at Black Dog Tech. So I'm just going to go ahead and take my Phillips screwdrivers, or Phillips screws, excuse me. Now, you may already know this, but I didn't learn this till I was probably in my late teens, especially if you're screwing into wood or something where, just in general, what I like to do when I'm screwing back in is apply light downward force and turn like I'm unscrewing, but apply very light downward pressure. And I don't know if you can hear it, but you'll feel it. That you feel it kind of click into place. That means you've engaged the threads. Let me make sure I'm doing it correctly again. There we go. So that way you're not crossing or stripping threads here, especially since you're screwing into plastic. Let's do the same thing here. And again, there's an arrow showing you where screws go. So again, countersink it. There we go. And screw that back into place. There are these little, I didn't mention this when I was taking the power supply out. There are these little tabs. Let's see if I can point them out with my tweezers. There's these little tabs right here. You kind of just have to bring the power supply in at an angle too. But it looks like it's, those are the only screw points on here. And if we were just doing the cap replacement, we would reconnect the power supply and reassemble. But anyway, that's it for the capacitor replacement on a PS1 power supply. Thanks for watching. Okay, I know I said thanks for watching, but I forgot one more thing. So you may wonder what all these are. These are actually the legs from capacitors. Now, foolishly, I used to just throw these away until I was doing a capacitor replacement on my Super Nintendo, and I lifted a pad on one of the capacitors. Now, thankfully, that particular capacitor, it was a through hole on a dual layer board, and which meant I could have bodged it to the proper trace from either side. And that particular capacitor needed to go to to ground, and there was a nearby ground plane and test via going through the ground plane. So I was able to scrape off the solder mask. These capacitor legs are really great for bodging connections. You know, you're like repairing traces and stuff. They take solder very well. They're easily bent, and you can easily take your flush cutters and cut them into smaller pieces. So I've been saving these. They're really great. You know, if you need to just join things, or you know, do bodging or trace repair. So I just kind of like to keep them until I can find a more long-term storage. I've just been keeping them in this big magnetized part here. But anyway, that's just a little tip I learned recently as well. Thanks again. Have a good one.